Hi, Osama is here. In this video, I will talk about two MIPs, the 3.8 collapsed as built subtractive single simulation and the 3.9 collapsed as built subtractive multi-simulation. These are the subtractive methods as per the RP 29R-03. We will start with the 3.8, the single simulation. Here is the concept of this method. I'm gonna convert the as-built into as-planned version. I wanted to show you some snapshots of Primavera to make the concept easy to understand. So let's say take for example excavation. I am dealing with the as-built right now. This is my actual start and the actual finish, and this is my actual duration. So clearly there is a delay and we are trying to analyze it, 5 days delay. I'm gonna show the original activity as planned, the excavation, which was 10 days, originally, because that's my original duration. I wanna also add the employer's delays, which are 4 days in this case, and the contractor's delay, which is 2 days in this case, right? The overall, if you can see, the overall dates should match the as-built, but in as-planned form. Basically, I want to create a new schedule from scratch. I will run the schedule at the contract start, but I'm gonna create a new schedule that will present the delays and also match the as-built. So that's only one demo, one example for excavation. But what about compaction, for example? Maybe in my baseline, the compaction and excavation relationship is finished to start, but maybe in reality, there is an overlap. So when I create this new schedule, I'm gonna reflect that. So I'm gonna introduce a start to start relationship with a specific lag. The whole purpose is to match the planned dates in my new schedule with the as-built actual dates, but in new planned form. So that's the concept in a nutshell. You can add activity codes. So for each new activity that I added, I can code it under employer's delay or contractor's delay. I can also code it under a specific category like excavation delay, because maybe sometimes later on I wanna have another presentation of different categories. So I'm gonna see all excavation, concrete, finishes, delays listed out for me. So that's one way to look at it. So after I created the new schedule, I'm gonna perform but-for analysis. So that's why the collapsed as-built is also known for but-for analysis, right? Both terms are being used in the same context. So if I want, maybe hypothetically, because the project is already in delay, it has been delayed by 2 months. So I'm gonna run hypothetical analysis. If I dissolve the employer's delays, then the outcome will be the project completion, but for the employer's delay. It's basically the project completion, including the contractor's delay. You can have different, and when you dissolve the events, you can recalculate the schedule. What are the source validation protocol? I need the as-built validation, right? Because I wanna create the new schedule based on my as-built. I need my delay ID. I don't really need the baseline, if it makes sense. It's under enhanced implementation, but it is not the minimum requirements. I don't also need update validation. I need the as-built information to convert the schedule or create a new schedule in as-planned form. This is the minimum implementation protocol under the RP. It's similar to what I have just explained. You want to create a planned version of the as-built, convert actual dates into planned dates. The result in this case will be collapsed schedule. Tabulate and justify each change you made to create the collapsed schedule. That's why it's a very time-consuming method. You can dissolve the risk events to perform the but-for analysis without adjusting any logic or lags, unless each instance is justified and tabulated. Enhanced implementation protocol, reconcile the as-built to the as-planned schedule. It should correlate and match. You can use all schedule activities. Do not want to miss activities if you want to enhance the implementation protocol. And also use a calendar simulating actual weather conditions to account for the non-work period. specific implementation protocol, determine the duration of each activity. You can use calendar days, so you will not go through the hustle of working calendars, so it will be easy to reconcile and do your analysis. And as I mentioned, convert the as-built logic to as-planned using different relationships if necessary. Maybe you want to use start to start with lag. If you remember, I gave one example about compaction and excavation. It was supposed to be finish to start relationship as per baseline, but there is an overlap, so I want to reflect that in my new schedule. So I wanted to adjust the logic so it can reflect the actual dates. So I choose start to start relationship with a lag. Consider all practical predecessors, because the non-driving relationships can become driving during the analysis. Some people might think I'm gonna link the driving predecessors only, but what happens when you collapse the schedule and dissolve the delay events? Maybe the driving predecessor will not be driving anymore. So that's why even though there is a predecessor that is not driving the relationship, you can introduce it anyway. For example, when we install light fittings inside the building, we need the false ceiling to be completed, and also we need the doors to be installed for protection and security. So we want to introduce both relationships. Although it makes sense that the doors installation will drive the relationship, but I'm gonna introduce the false ceiling anyway because it's a practical predecessor. Advantages: the concept is easy to understand and implement. It uses actual events and substantiated records. There are many disadvantages to this process. The process is very detailed and resources consuming. And by resources, I mean the practitioners, like planning engineers who are working on it. Time, effort, and energy, they are all resources to be consumed if you want to perform this method. Creating the collapsed schedule required subjective decisions, and therefore might be subject to challenges by the opposition, because I might have a specific perspective on how to introduce the relationships, but someone else might challenge me, they might have a different view. Subject to manipulation, because I am creating a new schedule from scratch, maybe intentionally or unintentionally, I can create manipulation that will not reflect the reality. The critical path of the new schedule might be different from the critical path of the schedule update itself, which key decisions were made upon throughout the project. Critical path is a very, very important element. Okay, it will help us measure delays and also make decisions about the project. But when you create this new schedule, the critical path might not be what you think or what you had in your schedule update. So this is also one disadvantage. So the critical path might not be practical. The method can be perceived as hypothetical. Uses: if you want to isolate owners and contractors' delays, maybe it's a good method. It can be implemented without having schedule updates. You only need the as-built. So it's one of the uses if you don't have schedule updates. Limitations: the accuracy depends on the creation of the after the fact reconstruction of events that doesn't refer to schedule updates. So everything is hypothetical. It's based on your own perception. Few practitioners have experience in this method. It creates the potential of missing scope if there is no sufficient data. That's one limitation, because if you want to create a new schedule, you would better have strong sufficient records to correlate when you create the new schedule. It is not suitable for identification and the quantification of acceleration, because the as-built already incorporates acceleration. When we identify acceleration, we might want to look at the progress during a specific window, for example, and we want to see how we perform, later on, so we can identify acceleration. But what I can see is the as-built only. Maybe there was some acceleration in between, but I am not able to identify that. The method is modeled. I model the delay by adding new activities. It's adding and deleting, of course. It's a subtractive because you delete activities to perform the but-for analysis. Periodic mode, global extraction. Maybe I wanna dissolve all delays at once under a specific category, or like, maybe all employers delays at once, or all contractors delays. It can be stepped extraction individually or in groups. So maybe I do not want to delete all employers delays at once. Maybe I wanna delete concrete delays only, or I wanna delete a specific event and I wanna see the outcome. So that's a stepped extraction. Now let's talk about the MIP 3.9 collapsed as built subtractive multi-simulation. I wanted to combine both methods in one tutorial because they are exactly the same except for one difference, which I'm gonna talk about. Source validation protocols. Again, you wanna need as built, you need update validation as well, and I'm gonna explain why. So that's the only difference. You need delay ID, and under enhanced implementation you need a baseline. So in the 3.8 the update validation was under the enhanced implementation, but in the 3.9 it's one of the, let's say, minimum requirements or recommended SVPs. The method is exactly the same, but I'm gonna dissolve the delay events on stages from start to finish or finish to start. This is as per the RP, but I prefer finish to start. You wanna start removing the delay events. You remove the delays starting from the project end and collapse back to the baseline. So let's look at one example, okay? And when I introduce all delays in the schedule, the new schedule, so let's look at the employer's events, for example. Let's assume that I wanna delete the employer's delays. So this delay was in July 2021, okay? There are two modes, but let's talk right now about fixed periods. So I'm gonna dissolve similar delays from finish to start. So I'm gonna start, if I'm gonna do it on monthly basis, I'm gonna start with the last month in the project, and I wanna delete employers' delays that occurred in the last month. I will run the schedule and I will note the outcome. I'm gonna still use the same schedule. So I'm gonna go to the window and I'm gonna collapse it back, okay? And I have another slide to explain it in a better way. So that's one example. I have my activities listed here and I introduced the delays as I explained before. So in the collapsed, in the 3.9, I will look at the last window because I prefer finish to start as a collapsing mode, and I will delete this risk event, okay, or dissolve it. Then I'm gonna run the schedule. I will note what happened, okay. Then I'm gonna still use the same schedule because I have one schedule in as planned form and I introduced all activities and delays. So I'm gonna use the same schedule and I will go to the window before, okay, this window. And I will delete the delays that occurred in this window. Then I'm gonna run the schedule. And I do that until I collapse back to the project start. The problem here is you will often need to redo the exercise more than once. Why? Because sometimes, in many cases, the logic will not be perfect. You think that there is, it's perfect, but sometimes you miss predecessors. The logic will not be 100% accurate. Sometimes when you do the analysis in this window and the outcome is not really practical, like there is wrong logic, there is something that needs to be fixed because everything is based on after the fact logic. It is not natural. You have the facts, but you introduce the logic based on these facts. Okay, it's the other way around. When you develop a baseline, right? You develop the logic, then the facts will come later. So when you do so, maybe it's not a practical, so you cannot really fix the issue on the spot and continue the analysis. As a best practice, you have to make the changes and fix the logic problems, then redo the exercise from the beginning, then go back, to the first window here and remove the delays and collapse back to the baseline. So sometimes you really need to redo the exercise more than once because you will potentially have some logic problems. So that's the only difference between the 3.9 and the 3.8. Okay, we're gonna have the same schedule, but I'm gonna do that on stages. And when I talk about removing the delays, it's really up to you, and this is a part of the periodic mode, which we will talk about in the next slide. So it's a modeled, you model the delay by adding or and deleting new activities, and it is also subtractive because you delete activities to perform the but-for analysis. In my analysis, you can choose fixed periods like I showed you, maybe monthly basis. So all delays extracted at once on monthly basis. And you can choose employers delays or contractors delays or all delays. Stepped extraction, it's more specific. So maybe you wanna extract the delays individually. So it doesn't account for the fixed periods. It is not a factor in my analysis. I'm gonna maybe extract specific event or a specific delay and see the outcome, or I might choose to remove all concrete delays and see what happens. So this is for stepped extraction. And this is it for the 3.8 and the 3.9.